Welcome to Lesson 6. Today you'll create programs that use repetition, trial and error, and your knowledge of angles to make gorgeous designs, and decompose shapes into small repeatable sequences. First, log into your code.org account. Make sure that you see yourself logged in to it by looking in the upper right corner. Work out the puzzles on your own, reading the instructions on the page, and watching any videos presented. If you get stuck, head back over to this video and find the section on that puzzle for help. You can pause this video now and begin. Puzzle instructions give us a big help by telling us that the equilateral triangle sides are 100 pixels long. We also know we only have 4 blocks to use, so I'm thinking we're going to need to use some pattern recognition. I'm going to first build a sequence for the triangle, and let's see if you can find the pattern. Move forward 100, turn left some amount of degrees. If you don't know how many degrees to use, you could use trial and error. Let's try 60 and put another move forward. Press run to try it. That's only half of the turn that we want. See, this interior angle of an equilateral triangle is always 60 degrees. So if I take a 180 degree turn and subtract 60, that means we need to turn 120 degrees. So let's try 120. That's better. Now I'm going to finish the sequence. That works, but we're using too many blocks. I'm now going to move this stack around and see if we can find a pattern. See it now? How many times does it repeat? Good, 3. Let's use a repeat loop. Ta-da! Great work! Pause here and go on to the next puzzle on your own. Keep going until you need help. Come back to the video if you need me. Puzzle 2. Watch the video about variables first. This looks similar to the last puzzle, but now we're going to use variables. We are going to set the length of the triangle to 150 according to the directions. Then when it runs, it will automatically make all of the lengths 150. The nice thing about variables is that if we ever wanted to change that value later, we just have to change it here at the top, and it will change the length everywhere in the code for us and save us time. Bada boom, done. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 3. Again, it's so important to read the directions and not try to guess what it wants you to do. Drag a number block to the set length block and to the repeat blank times block to draw a set of 50 pixel triangles. The length represents the side of the triangle, which they tell us is what? Yes, 50. So we'll put a 50 here. And how many times are we repeating these triangles? I count 6. Great job! Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 4. This is a pretty looking design. According to the instructions, it's made out of hexagons. Look closely for a minute and try to see those hexagons as they turn and overlap. Great. The instructions want us to set the length variable to 60, but I want to take a minute to look at all of this code it gave us and try to figure out what's happening. Okay, we're setting a random color. We're repeating something 6 times. Move forward and turn left. They're dividing 360 degrees by 6, probably because there are 6 angles to a hexagon. Then it turns left 60 degrees before starting the next hexagon. Okay, now that I understand what's happening, let's put in set length to 60 pixels. Great job! Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 4. Draw this pattern of pentagons with 100 pixel sides by setting the right value for length and dropping the length variable into all of the correct places. Before we do this, let's check out the stack of code. If I break this into parts or decompose this stack, I believe this repeat 6, move forward and turn left represents our pentagon. But it's curious that they are repeating 6 instead of 5. Maybe it's to get it turned one more 72 degrees before it starts the next pentagon. Now let's set up our length to 100 pixels. See how you only have to set the value for length once, and the code uses the right value everywhere? Great job using abstraction to insert variables for lengths. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 6. Now I want to make a rectangle that is twice as tall as it is wide. We've got a variable called width that needs to be set to 100. Can you use the math blocks to complete the code? So let's set the width to 100 like it says. This stack shows a pattern moving forward with pixels, turning 90, move forward blank pixels, and turn 90 again to make a rectangle. How many times are we going to use the width to make the length? Good, let's try out the 2 and see if it's long enough. Good work using width as a variable. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 7. Here's some code that can draw any regular polygon. There's a new variable called sides that is set to 4. Can you use the sides variable along with the math block to turn the right amount regardless of how many sides are in the polygon? It looks like there's also one hint. Let's see what it says. So a square is a regular rectangle with how many sides? So let's divide 360 degrees by the number of sides. We could put a 4 here, but what if we want it to be more universal so that it would work for any regular shape by just changing this 4? Let's put the variable sides here and see if that works. Great job using abstraction and utilizing sides as a variable. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 8. Use what you learned in the last puzzle to create this hexagon using the sides variable. The move forward already is set to 150 pixels for us. We need to set the number of sides and use the variable everywhere else it goes. Take a moment and try that now. Okay, I set sides to 6 because it's a hexagon, and then use the variable sides here and here. Great job using abstraction and utilizing sides as a variable. See how you could change just one value to draw a triangle, square, pentagon, or octagon? Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 9. Look back and study the previous puzzle if you need to. We are going to recreate that algorithm for a regular polygon for this pentagon that has sides of 150 pixels. Pause and try this on your own right now. Look back at puzzle 8 if you need to. Did it work? Here's what I did. Great job using abstraction and utilizing sides as a variable in an algorithm. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 10, free play. Experiment with the number of sides the shape has. Can you change the algorithm so that the overall size of the shape stays the same, no matter how many sides it has? After you try it out, press finish. Pause here and try the next puzzle on your own. Puzzle 10. Here's some more complicated code using the same concept from the last puzzle. What should you set the sides variable to in order to draw this picture made out of squares? Let's look at this stack more closely. Here we repeat moving forward and turning by the number of sides. So that gives us a polygon. After we make the regular polygon, we move forward and turn right to get lined up for the next polygon, I guess. Let's see what happens with 3. And then let's change it to 4 for a square. Great job using abstraction and utilizing sides as a variable in this algorithm. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 12. Let's set the sides variable to 5. The more sides we add to this algorithm, the bigger the whole pattern gets. Notice that there is another variable called length. We can now use that variable wherever we have a move forward block. Set the length variable to 75 for the shape. Pause and try it now. I'll set the length to 75 and number of sides to 5. For move forward, we need to put in our length variable. Great job using abstraction and utilizing sides and lengths as variables in an algorithm. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 13. When a shape has lots of sides, each side needs to be shorter if you want the whole pattern to fit on the screen. Let's create the algorithm for this amazing pattern. But instead of manually setting the length variable, let's use a math block with the sides variable inside to make sure that the shape fits correctly. The perimeter of each polygon is 300 pixels. That's good to know. So the length of each side would have to be 300 pixels divided by the number of sides. It looks like there are also 3 hints that you're welcome to look at for this one. One other trick to help you might be to copy and paste the stack from the last lesson. I'm going to go back, click on the top of the stack, and do Command C or Control C to copy. Then I'm back on 13 and I press Control V or Command V to paste it. Let's make changes as needed. What should I change? Let's use a math block for set length and change the number of sides. Great job using abstraction and utilizing sides and lengths as variables in an algorithm. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 14, free play. Check it out. Now your algorithm is nested into one more loop. Experiment with changing the values of your two variables to draw cool patterns. For even more effect, try playing with color. Use random colors inside loops to see how it changes your design. When you're done playing, press finish. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 15. There are 4 hints with this one. Now you've learned everything you need to know to make a pattern like this. If this picture inspires you, try to make something similar. Otherwise, create something all your own. When you're done playing, press finish. Pause here and try the next puzzle on your own. Come back if you get stuck. Puzzle 16 is for you to continue playing. Feel free to copy-paste some of the code over to this puzzle and then edit it for more fun. Add some color changes, or stamping of stickers, or make the lines fun patterns. And when you're done playing, press finish. Great job today. Make sure all of your bubbles are solid green and have a great day.